Good morning. My name is Brianna, and I will be your conference operator today. At this time, I would like to welcome everyone to the APM Global Community Webcast Why Upgrade to APM 10. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I would now like to turn today's conference over to David Martin. Please go ahead, sir.
Good morning and good afternoon and good evening. I know we've got people in all different time zones. Here in Santa Clara, we are, I don't know if you can see my video here, powered by green tea. So hopefully you have a beverage of your choice handy. I'm going to try and pack this hour with as much useful information as I can. Just as a brief introduction, I have some deep background in the space. I started with Wiley Technology early in the year 2000, which was close to the birth of Wiley. I was here in 2006 when CA Technologies acquired Wiley. I'm now in a product manager capacity, and one of the features that you're going to hear about in APM 10 is a feature that I manage, so I'm going to spend more time on that feature in particular. It's called differential analysis. But you can ask me detailed technical questions if you have them. If I don't know the answer, I will get back to you. I'm hoping this can be as interactive a session as possible with this particular format. So with that, I will jump into things. Somebody let me know that if I pick my nose or something like that, I'll try not to do anything ugly. But video is not something I have a lot of experience with. So APM 10, what is APM 10 all about? I have some good philosophy type slides here. In the new economy, all different things are connected that weren't connected before. And one of the problems that our customers are always talking about is how APM and the APM space in general has always been very descriptive. And this is not a criticism at all that's exclusive to CA. This is something that all the products in this space struggle from. You give customers a ton of information, but you don't necessarily give them a whole lot of clues about what to do with that information. And everybody's working towards that, but especially here at CA Technologies, we have been focusing on that, and you'll see how that's the case. So a lot of APM models, again, are full of this different types of information. We need to do better. We need to grow towards something where we're teaching our users what to do with that information rather than just providing it. There's more to it. You know, this particular slide talks to the fact that in most shops, there are people that are more technical than others. And we have started talking about those people as the surgeons. The surgeons are the go-to for some of the most difficult problems. The surgeons can do things like read thread dumps and diagnose deadlocks and maybe even figure out the code necessary to remove those deadlocks, even in third-party code. But not everybody can do that. And in your enterprise, you need people that can be effective about at least triage without those kind of medical school skills. So just a few different pictures of maps that get produced by these APM tools. They end up just being far too detailed to actually be useful. So one of the cute ways we've talked about this is that we can't get into the habit of putting surgeons on the ambulances, right? In real life, we don't do this. We keep the surgeons in the ORs, right, in the emergency rooms. And the ambulances are there to do the initial, not just identification of the problem, but triage of the problem so that on the way into the hospital, the right sorts of experts are already lined up so that when you take the patients off the ambulance, they're ready to be dealt with properly, right? So in APM 10, some of the ways that we started to do this is we went to our users and we did what amounts to ethnographic research of how they're doing their jobs. So again, that's not entirely new to how people do product management or figure out strategy for products. But what we did at CA is we actually implemented Alan Cooper's methodology. So Alan Cooper is famous in the software field for a string of books and a consultancy. One of the most famous books is called The Inmates Are Running the Asylum. The Inmates Are Running the Asylum. If you haven't checked that book out, that would be worth a quick read. The idea in the book is that a lot of software gets built with the expertise of the software builders in mind, meaning the software engineers and that actually put the software together. And those software engineers rarely have the same perspective on the software as the people that actually use the software. So what Cooper advocates is identifying what he calls personas. So a persona is not a specific person that you interview. In fact, you interview lots and lots and lots of people, and then afterwards you start to do some detective work to figure out the roles, and that's a good way to think of personas, that are underneath all those different people you interviewed. And when we went through this process with APM 10, we did find a group of people. So obviously these are pictures of actual people, but the names that are below them are names that we gave the personas. And then there's a short little title that goes along with them. We have much longer descriptions of who these people are in terms of the roles that they represent to APM 10. So for example, Kyle is the guy that's had to traditionally do an awful lot of the work associated with APM, in that Kyle was the one that not only had to install the product stack, but often had to set up alerts, and he was pretty lonely in the things that he had to do. Lately, we've gotten a lot more sophisticated. We have people like Pete and Ryan that are directly working with the product, and now somebody like Pete may be involved with figuring out what alerts to set up or how to interpret the alerts. Pete is somebody that I've spent a lot of time thinking about and serving with the strategy that we've got for the product, what we did in APM 10. And when I get to differential analysis, I'll talk about why it's important to Pete. But Pete typically reports to Ryan, and Ryan is kind of the next level of support up. So he may not be a surgeon himself, but he'll have some of the surgeon-like capabilities. So as we do triage and we go out into that battlefield of applications and we try to find the ones that need attention, Pete and Ryan are the ones that are working together in what is called triage. Sometimes people use the word triage to mean diagnosis. That's not what I mean in this case. We'll talk about that more. Diagnosis might be more in the domain of somebody like Andrew that you see in the upper left. Andrew can be drug into a DevOps situation even if that's not his role. And in fact, in some shops, we're seeing that the Andrews are the Petes and Ryans. This is something that companies like Netflix have popularized, where the developers are themselves the production support. So there's a whole bunch of other people I can talk to here, but what I wanted to get across is that CA Technologies has committed fully to this Cooper design approach of thinking about our users, and it's been very successful for us, and we're going to continue with it. So I've talked about them a little bit here. So let's get to the actual software. So in APM 10, there's a couple of new marquee features. One of the features that is at the heart of APM 10 is this new Team Center, we call it, or APM Team Center. Sometimes you see it abbreviated as ATC. The Team Center is what gives you this topological map of your applications and their call paths. We had taken a cut at this in the past, but we have really committed to having one that takes a lot of complexity in your environment and brings it down onto a simple level. So let me actually go ahead at this point and cut over to sharing with you a picture of what Team Center looks like. Okay, so here you've got a map in Team Center, and you've got a tab selected called Perspectives. And what is Perspectives about? Perspectives is about observing that, hey, you know, I've got 249 devices in my map topology picture here, but if I try to paint all 249, I just get an eye chart, right? So what Team Center lets you do is you can actually select to look at those different devices by their unique OS. And then the picture collapses into showing you, okay, I actually have 2 Chrome devices, and I have 7 iOS devices and 2 Android devices over here. These groups get put together, so if I take this off, let's get rid of one of the perspectives here, or I can shift to another perspective, say by owner, the groupings change, right? So there's a different group of owners here. There's a different, if I group by type, this would be like, you can see the different component types here. So we've got a set of business transactions. We've got, wow, over 100 different servlets, but all that complexity gets broken down by this perspective. So if I click on, if I actually blow up the servlets, now you can see there's all of the different complexity of the servlets are displayed here. So I can glide over the servlets, and you can actually follow call paths out to the backends and the databases here. So a lot of products have maps, but what's special about our map is this ability to almost relationally, if you're familiar with SQL, do joins and order bys and groupings, so that you can get a visual picture according to whatever the attributes are that you want to look at for those different environments, right? And of course, because there's so much complexity, besides grouping by perspective, you can filter, you can highlight by different attributes in the system. So by a particular email address, that's an attribute to a component. And then we also have a timeline. So if there are things that are happening in the environment, alerts that are going off, topological changes, those are going to get displayed on this timeline. And it's actually stretchy, right? So you can glide over time periods here. You can start to see that there are alert nodes showing up, different cautions and danger thresholds. And we're going to get to differential analysis in a second, but those metrics are shown here too. Now there's also a dashboard tile here that's going to summarize all those different components, in this case by type. But I could filter or change from type to owner, and again, it works a lot like the perspectives do. So I'm going to go back to the slides for a second. So Team Center is one of the ways that we take that huge set of complexity and we render it into a more simple picture that's suitable for Pete, Ryan, for Andrew, for whoever it is that's doing analysis of the environment. So before I roll on to some of the other features, I'm going to stop. It looks like we're about 15 minutes in, so it's a good time for that. And ask Brianna if there's anybody on the line that has questions. I'll take a quick look at my, I think there's a hidden Q&A panel here.
Okay, as a reminder, if you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. We'll pause for just a moment.
Okay. Well, there are videos out there that show a diagnostic path through APM Team Center, including the APM 10 video that's available. Oh, looks like we got one question. Okay. When adding a filter in order to organize your applications, what permissions do you need to have? The APM documentation states that you need to ask the Team Center administrator. What permissions do you need to have, and where are those permissions set? So yes, it is the Team Center administrator that has those capabilities. Kind of like with APM as a whole, we don't have an incredibly granular set of permissions. There's roughly the admin level and then various grades of regular user. I'm actually not sure where the permissions are set for Team Center. So Ed, I'm going to have to get back to you on that one. I'm making a little note to myself here. But good question. One thing that I can tell you about Team Center now, because I've been playing with this myself, is here, I don't want to dismiss these. When we go back to the map picture, one of the exciting things that we're doing here, I'll go back to perspectives, and I think I can shrink this down. Here we go. Put that back into the picture. Load this up. Yeah. There we go. If I click on one of these components, I'm going to have to close this window, or I'll move it for a second. I don't want to miss a question. And you, whoops, if you look on the right side here and scroll down, besides all of the blame point metrics that you're used to seeing in WebView or in a console, there's a set of custom attributes here. So there's actually now an API you can use to decorate the map with custom attributes. So one of the things that we're doing right now with the product that we're developing is we're using that API so that from the APM side, when we see interesting things happening in groups of things, without going too explicitly into what we're building, you can decorate the map with custom attributes that correspond to that information that you've discovered. And then when you come to Team Center, you can actually pre-select into these perspectives to find them. So this is going to be, I mean, right now, it's pretty exciting to see what's there, what they were able to do with the APM 10 release, but this is a foundation on which we're going to be building a lot of semantically rich APM information moving forward. So I kind of digressed, but thanks, Ed. Does anybody else have any questions before we move forward? I'll give it just a second. It's time for me to pour my green tea, so I'll give this a second. Green tea. I don't know. I drink coffee too, but in the morning it seems like green tea sometimes is the best. All right. Well, I'm not seeing any more questions come in, so I'm going to switch back to talking a little bit more about the what's in APM 10 slides. Close this for now. And what we're going to get to pretty quickly is this differential analysis feature, right? So at this point, I actually have a separate deck that I've been preparing. There's a lot of words in the deck. It doesn't have as many pictures as here, but I'm going to try and take you through it quickly. It was the feature I managed, so I apologize for being so excited about it, but since I know a lot, I figured you guys wouldn't mind hearing about this feature in more detail. I think that in some of the APM 10 messaging, some of the detail of what we did got lost. So I will switch. Let's see. We're going to PowerPoint going to let me switch here. Here we go. All right. So to set the picture here, there is a history to what's happened in APM. So when APM started, the obvious thing to solve the problem of alerting was to ask the customer to go ahead and set baselines. And by the way, that's what we call static alerting here at CA. Static alerting is still useful. If you have SLAs, you know, for example, you said all of our transactions or 99% are going to be below 3 seconds. There's no way that any software is, to use the Latin term a priori, going to be able to determine what those thresholds are. You're going to have to teach the product that. So that's not going away. But that's not the bulk of the problem. The bulk of the problem is that people like Pete don't know what thresholds to set, right? And so the holy grail is for customers to light up their solution and have that solution automatically calculate the right baselines for alerts. And we took a pass at this 10 years ago. We were one of the first, if not the first, to introduce the idea of using some math to do double exponential smoothing or similar for looking at the baselines. And the fact is that that first attempt did not work out, right? And the reason it didn't work out, at least you'll see part of the reason it didn't work out, was that it didn't take into account situations where the environment is changing in a regular fashion, right? Now, everybody likes to talk about load as a regular production event. The obvious thing is like, oh, there's a big increase in load, so that's going to be what they call seasonality, right? On Mondays at lunch, you get the heaviest load. Well, there's seasonality in transaction volume for sure, but in most environments, you don't want to see a change in response time as a function of load, at least not much, right? So looking at response time is actually different from looking at transaction volumes, and when you talk about seasonality, those have different meanings. So a lot of products in the market understood that seasonality was important, regardless of what type of metric you're talking about. And they built daily, weekly, monthly, even yearly seasonality in. Annual seasonality may largely be relevant to retailers and nobody else, but you know, that's the type of thing that is out there right now. The problem with that approach is that it still doesn't really capture the actual situation. And when I say the actual situation, I mean that there are lots of events that take place that are during those regular production windows that actually should be considered a problem. And there are other events that are outside the production windows that happen, and you know what? They're generating alerts that really you don't want to pay attention to. So if you look into the documentation of some of these other tools that have chosen this approach for their automatic alerting, they'll have sections where they talk about putting rules on top of the baselining engine, even with its seasonality. And those rules will say things like, you know, unless this is 3 standard deviations away, don't alert on it. And it's interesting that they do that, because you're going to see how that feeds into what we decided to do. The point there is that if you start putting if you start having to apply rules, well, then at some point you're going back to that static alert threshold setting, right? If you only have to apply 1 or 2 rules, well, then maybe it's not that big a deal. But what we're hearing from customers is that even when you take this fancy baselining approach with seasonality and other adjustments, the customers are telling us that they have to set a lot of rules before they're really getting a good alerting experience. And just like with the static alert setting, you know, those rules need to be maintained. And there's always this chance that when you set a rule to deaden the sensitivity of a particular alerting line, you're going to lose an important alert. All right, so what the heck did we do, right? So I kind of talked through this just now. When you look at a response time of an application, say, there's a fair amount of bounce in that. And, you know, the smoothing algorithms, like I talked about, have seasonality to them. So this isn't a perfectly accurate picture of what's done. But, you know, let's say for the purposes of this discussion, and it's fair to do this math-wise, we're talking about a period when seasonality didn't apply. In this application, you're seeing response times bump between, you know, roughly 500 milliseconds and 550 milliseconds. For a lot of applications, that's a pretty typical response time, nothing too alarming. Now, one issue is a situation where the application has an outlier, right? And this is just what I was talking about. If the application has an outlier, the automatic alerting system has to make a decision. Do I send an alert and risk bugging Pete, the operations guy, right? Or do I decide, you know what, that spike wasn't big enough, so I'm not going to send an alert? Maybe the customer set a rule. They have regular spikes in the application, this application, so they had to write a rule to say it's got to be bigger than a breadbox before the alert goes off. At CA, the observation we make about this situation is that if there's a single outlier or a small group of outliers that amount to a blip on the screen, it's not even a joke. To be cute, what we say is that the ops guy won't even put down his or her sandwich, right? Because if you're dealing with a high volume application, yeah, customers do matter, but really you want to look at the traces for those customers. You don't want necessarily the automatic alert to trigger the light to go off or the bells and whistles to go off. So that's one situation where the traditional approach has problems, right? Maybe it doesn't fail, but it at least has a lot of interesting questions that need to be asked before you can figure out what to do. And a lot of those questions are going to end up back at the end user. Let's talk about another situation. Okay, so in this case, we actually have a sustained change in the response time of the application. So it wasn't just one outlier. It was some sort of an event that took place over time, right? Now, here again, we have the question of when do we alert? If the baselining algorithm considers this a period where there's some sort of seasonality, it's going to swallow this activity. But looking at this picture, is this the kind of activity that necessarily should be swallowed? Well, you know, I haven't shown time on this. If this lasted 30 seconds, do we swallow it? Yeah, probably. If this lasted 30 minutes, no, we shouldn't be swallowing this. But again, the decision about when to alert, it kind of ends up back on the end user if you're using that traditional approach, because if this is seasonal and normal, well, then the alerts get swallowed. If this is seasonal and not normal, the alerts get swallowed, and it's wrong for them to get swallowed. The point is that a real operator is going to look at that time span and look at the sustain on this, and that's what's going to lead them to make the decision. If you have a human being watching this, they'll do the right thing here based on how long this lasts and how big a spike it is. But if you're relying on that baselining with seasonality, it's not intelligent enough to balance all those variables together. And the situation is the same when you have long periods. Now, if you have long periods of activity like this, the question becomes like, you know, what's going to happen to the baseline during this period of time? So again, if this is irregular, you're going to have to write rules. You're going to have to write rules to make sure that this doesn't go off, right? So what do we do? Okay, this part of the story I really enjoy telling, because I really am somebody who believes that in most cases, if not all cases, a problem that you have is a problem that somebody in history has solved before you. And I think in computing we get used to thinking that all of our problems are new because computers are quote-unquote new. But it's not true, right? And in particular, in the 1920s, this guy Walter Shewhart and some of his colleagues who worked for the Western Electric Company, which did a lot of work for AT&T, were trying to figure out how to monitor the quality of buried telephone lines. And what they found is that the traditional approaches of modeling the lines had problems. And guess what? Their models are just like the baselines that we've been looking at, right? The problem with the model is that when the model breaks, you don't know if, when something happens, you don't know if something happened because the model found it or something happened because the model was broken, right? So what they did was they made some simple observations about how to watch the signal, and those became known famously as the Western Electric Rules, and they earned Walter Shewhart the title of the father of statistical quality control. All right, you know, when my colleagues and the CA data science team first brought this up, I don't have a degree in math. I do have a degree in computer science, and I was a little concerned this is going to be too complicated for me to understand. You know, like the Holt's linear exponential smoothing, like I've looked at the algorithm, but it's not necessarily something that I get. So can we understand what the Western Electric Rules are? Well, yes, we can. They're actually pretty simple. And some of you are going to look at this and say, hey, that looks a lot like the rules that people are manually applying. And like, I don't think that's an accident, right? So the idea of the Western Electric Rules, all you need to understand from a math perspective is what a standard deviation is. So for those of you who don't know what standard deviation is, the rough idea of standard deviation is that it tells you about the variance within your signal. Like, are you varying on average, or I don't know if the right word is on average, but are you varying by 5 milliseconds? Are you varying by 50 milliseconds, by 500 milliseconds? What's the normal sizzle in the line, right? So by having a notion of standard deviation, what Walter Shewhart did is make an observation that sometimes something really unusual happens, an outlier, and we'll call that rule number 1. Okay, so in this case, rule number 1 corresponds to a single measurement that's more than 3 standard deviations away, and you can adjust how many standard deviations you want to use for these dotted lines, but that's the idea. Rule number 2 is more subtle. It says if you have 2 measurements out of 3 that are beyond the second standard deviation or equivalent, that's not as big an outlier, but that's also something that we could consider of concern, right? And 3 and 4 get gradually more specific, right? You can get closer and closer to normal, but if you're not normal sufficiently, then you're going to break those rules too. Now, the first thing you might be thinking as I show you this is like, oh, well, that's too simplistic. Just like you were saying, if you break the 3rd standard deviation, that may or may not be an outlier that you care about. If you were thinking that, right you are. We didn't just implement these rules directly. What we did is we made the observation that these rules could have a weight associated with them. And on each measurement, we look at the rules and we say, did we break any of them? And say rule number 1, that outlier rule, that's an important rule. So if we break rule number 1, we're going to put a fair amount of weight into a window that we're calculating, right? And then as time moves on, that weight that we dropped in, it slowly ages away. And I have a picture for this that I'll show you in a second. And so nothing happens. If there's one outlier, we don't care, right? But if a string of outliers start landing, or we start breaching rule number 2 and rule number 3 and rule number 4, that window starts to load up with the weights of the rule breaches for the Western Electric rules. And this is the part, I'll skip right to the fun here. We don't just have a red, yellow, green alert. We do put red, yellow, green alerts on top of this, but what we calculate is what we call variance intensity. So in this picture, the white lines are periods when a signal was totally stable. The dark blue slats that you see in the picture are periods when the signal for some response time or application or component actually experienced a fair amount of instability, right? And I've got more pictures to come. Here's actually a blow up of what I'm talking about, right? So this iconic order select plan type response time, you see that there's an outlier popping up over the bands of standard deviation below. And then if you scan up to where we've got the tab selected, it's, we're still working on getting this perfect, but you'll see it underneath. It turns a little gray, but it doesn't turn blue. So that variance intensity that I'm talking about that measures the stability of the signal, it's risen, but it hasn't risen enough to go bother Pete, the operations guy, right? Just like I said, Pete isn't going to put down his sandwich for this. But if I keep moving through some of the other pictures that I've got here, look at this line. That line actually turned a pretty dark blue. And for the time period that we're looking at, it's roughly, 30, 40 minutes. That's something that Pete may care about. So Pete could be taking a look at this map. I mean, this map turns out to be a really handy way to do triage over, hundreds or thousands of systems. Or Pete may actually, in this situation, have gotten automatically an alert, because we will trigger an alert when the stability reaches that level, instability reaches that level. So what does that look like? Well, so I selected that line, and now below you can see there was a pretty huge anomaly in response time during that period of time. Now, we still implemented seasonality, so if it turns out to be the case that at 4:45 on whatever day you get this regularly, we're not going to alert on this, just like the others won't. But if not, if actually this is an anomaly and this is something that is a problem, the baselines that aren't learning necessarily what's taking place won't necessarily pick this up. And even if they do pick it up, one of the cool things is that on the left edge of that slope, with the feature that we implemented, we actually send a message to our agent and say, you know what, we've seen the start of a change in stability. So please, Mr. or Mrs. Agent, go ahead and start collecting some traces for me now, so that if I come back and look at this later, I can see some detailed pictures, and that happens automatically. This is a longer period of time, over several days. Let me move this so I can see exactly how many. Yeah, so this is about 48 hours worth of data. So I won't be able to get a voice from you on this easily, but if you look at this picture and you're the operations person and you're doing triage, and what you've done here effectively is you've run very quickly a report about the stability of your applications over the last 48 hours. Just by looking at this screen, can you visually pick out the places where maybe you should be spending a little more time focusing on? Like, check this out. Let's see if I can use my pen. All right. If you look at this line here, what's interesting is that the periods of instability didn't last that long, but this is a line where I would say the application has some kind of a chronic problem. The problem isn't acute, it doesn't last forever, but there's a recurring problem that's taking place at roughly 12-hour intervals for that particular application. So with the differential analysis feature to visualize, we actually have done some triage here. We've said, okay, in this picture, this guy looks like the acute situation that maybe we can click on, and maybe there's some acute here, although this one recurs too, right? But if you're looking for problems that aren't necessarily acute, but that you want to spend time on optimization or fixing issues in, your automatic alerting may or may not have picked up on these, right? But differential analysis pulls them out. So you can see that there's something further for you to focus on. A few more pictures of how that, we call, it's not green anymore, but we call the graph at the bottom the green highway because it shows the bands. And the idea is for your application to stay within the bands, to follow the, I guess in this case, blue brick road, right? So here's another example where the application went unstable and we saw a change in variance intensity. All right, so I think it's been roughly, it's been quite a while since I stopped for questions. So let me pause again and I'll take a look at, that's not what I want. Brianna, if you don't mind announcing question time again.
Certainly. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. And there are no questions at this time, David.
All right. Well, I have to admit, I'm disappointed, guys. Did I bore you? Somebody tossed me a bone on chat. Just say, here's your bone, Dave. Oh, okay, wait. It looks like we do have a question coming in. All right, so I'll wait a second here. Uh-oh, all right. Well, I'm going to assume you're not talking about your heart. So please, if you're driving, pull over. And if not, no worries. I'm not going to hold you on your spelling. Okay, we got 2 questions coming in, it looks like. All right, the alert level is shown in the dashboard. But where do we invoke an action, an email to someone to look at? Okay, so great question. So, okay, so yeah, Rogelio's is actually, thanks, there's the bone, okay. No, this has nothing to do with ABA. It's a totally separate set of functionality. Okay, and do I have, I think I'm sharing Chrome, so let's switch over here. I actually have differential analysis set up to take a look at. I think we're going to be in the sample module, management module. So the first thing, and I'm going to show you all the controls in a second, but I'm actually really, really proud of the fact that this is the configuration for differential analysis. You know, we're never going to be the iPhone guys, but if you look at what you need to do for differential analysis, out of the box we point at a lot of the high value response time metrics. You can write a metric grouping to point it at whatever you want. It's gonna work best with response times most likely, but you can experiment. And then these thresholds are all about how quickly do you go from white to blue. So if you lower the thresholds, you rise in intensity more quickly, and if you raise the thresholds, it's harder to go higher in intensity. So with intensity, what the heck am I talking about, right? So let me show you. If I go and I look at one of the agents that has differential analysis defined, like, let's see which one. One of these is, I'm not as familiar with this particular, okay. I think this one does, so that's good enough, right? Not under ACC, it'll be under WebSphere, right? Okay, good. If you look under an agent where you have differential analysis defined, there's a new folder in the tree called variance, right? And this is that breach sum algorithm that I was talking about. Under variance, you'll see the management modules in which you have it configured. And then under the management module, you'll actually see the response times or whatever other metrics you set up. And in this case, the default trading URL, this is a little deceptive here. It's not just average response time, it's the average response time variance intensity. So I'll click on that, and I'm going to keep on shuffling these windows around. Okay. Right now, the variance intensity is 10. So this is, I feel like I'm playing cards all of a sudden, moving these around. But see how the number is 10 for variance intensity? Variance intensity goes between 10 and 40. It's an arbitrary range, right? But what 10 means is that the application is totally and completely stable. 40 means man, we've loaded the window up with so many rule breaches that it's about to drop through the floor. So what can you do with that? Well, the answer is you can set up an alert. Here's the default differential analysis alert. And it has a nice, we hope, helpful message about what the different stability levels mean. This is where you layer the red, yellow, green on top of the variance intensity. So red, yellow, green is still a blunt instrument for talking about the stability, the quality of response times on an app. The differential analysis map and all of its beauty in terms of displaying those strips is still the best place to get a sense of what's happening with your response time. But we recognize the fact that people do want to associate actions, like sending an email, just like Todd is asking. And you can go ahead and, just like with a regular alert, you can pop an action into the differential analysis alert to go ahead and send an email or trigger a shell script or whatever else it is that you want to do. Hopefully that covers Todd's question. If not, Todd, write again to follow up. Naeem, I think it's Naeem. I'm not sure how Cloud Foundry is related. APM 10 is the latest release of the APM suite. So I know that we have folks that are working on Cloud Foundry, but I'm not sure how the question relates. So. Okay. All right. Well, that was pretty good. I'm happy that we're able to get a little bit of interactivity into this format. Any other questions on this one? I really wish I could just throw out like, hey, what do you guys think? Because I'd love to get some immediate feedback on what you think we've done with, how you think we've done with the feature. Yeah. And again, this differential analysis information here, I'll switch this to like 2 hours of time. It actually looks better and better with the longer time periods, which is kind of cool. Okay, I can pop up. There's the green highway on this one. Pretty nice. Heuristics. No, heuristics are playing an important part in other features like Team Center and also our 10+ release work. I'm doing something right now that is heavily involved with using heuristics. So I think the big thing is, and I don't know if those are, yeah, that's it's Rogelio. So he's thinking ABA. ABA used one type of multivariate model for anomaly detection, and inside the sausage factory here at CA, this differential analysis feature was known as univariate baselining, right? Because we really do, just like Schuhart did, we're taking a signal. You know, he took a telephone line, we're taking response times on apps, but we're looking at that signal and we're deducing stability by using that simple set of Western Electric rule math to talk about the state of the signal. So, and again, like the big thing here is that the feature mirrors what a human operator would do. If a human operator saw a spike, probably do nothing. If the spike sustained for some period of time, maybe they do something, maybe they not. It depends on the period of time. So you get out of the business of having to watch the toaster, so to speak, and you just let the system watch the toaster for you and give you a message when the toast is done, when it pops up. All right. Well, I will glance at these before we're done, but we're getting close to 10 minutes on the hour. So I will go back and dutifully cover. Oh, I promised this. So this is in the product documentation. I'm not going to try to completely communicate everything that's here, but this is a summary of almost everything that I've said so far about how differential analysis works. In the upper left, there's shorthand for the windows. Those probably should have been labeled with the math rules underneath, but you get the picture. Rule 1 is an outlier, Rule 2 is a smaller outlier, Rule 3 is an even smaller, and Rule 4 is strictly monotonically increasing signals. We don't like those. So the thresholding, like I was telling you, we have those slider bars, and if you push them to the right, it keeps the variance intensities lower for longer. And then in the middle, this is really the heart of how the feature works. Each of the rule breaches drops a certain weight into a window. So on the right is the most recent measurement, and on the left is the oldest measurement. You can change the size of the window, and the weight of the breaches is controlled by the thresholding that we just talked about. But the point is that whatever weight you drop and however many bits of weight there are left, that's the sum of the window, and that's what more or less directly corresponds with the variance intensity. And then with the question about alert actions, that's kind of what this bottom bit is about. You start with your response time metric, feed it into differential analysis. That creates a variance intensity metric, which we looked at. You put a metric grouping and an alert on that, and bing, now you can get email notifications in response to changes in stability. All right. So now I'm going to, oh, hey, I forgot about this, but these are the folks that built the feature. Yay! They were wonderful to work with, and we have 2 patents pending on this feature. We're very proud of it. So a few folks are remote, so we get the floating heads there. But all right, so now I'll switch back to that APM 10 deck, see if there's not a few more things we obviously talked about. Okay, so there are a bunch of other features which I just don't have time to cover completely. Some of them are covered by separate presentations, and you can find more information about them on ca.com, or you can send me a note and I'll connect you with more information about them. We have a change in how we do instrumentation. The agent will automatically detect the classes that are the entry points, meaning the ones that receive the transactions first coming in. So this is something that's going to bring our users closer to zero config. We're not at zero config yet, but we're driving in that direction for the agents. We've got new integrations with the mobile app analytics product and the browser-side agent there. BRTM is being worked on, which is now, for those of you who know BRTM, it's now being referred to as the browser agent. The Agent Command Center is a new UI for the daunting task of keeping track of all the agents that you have deployed, and that's actively being developed and features being added to it post APM 10 too. And then we've got new support for things like the HTTP correlation on distributed transactions, and there's REST support too that wasn't there. And then finally, there were some additions to the SAML features for customers that had security requirements that weren't met in the past. All right. We like talking about Epic APM. I actually wrote a song about it, and it's up on YouTube. So if any of you are a glutton for punishment, again, email me. In fact, what I'll do now is, like, there's got to be a way for me to, I think I will switch over to a whiteboard to put up. There's probably a better way to do this, but let me see here. Share a whiteboard, right? If you guys want more information about any of these features or any of the things that I've talked about, or you really, really want to watch or listen to that song that I put up on YouTube about Epic APM, drop me a note and I'll send you a link. There are 2 David Martins at CA. One of them is a very senior engineer out of Texas, and if you write to david.martin@ca.com, you will get him. So make sure that you put my initial in there, B as in boy. and then I will receive your message. And otherwise, it's still a few minutes to the hour, but I'd actually like to open it up for questions again, because I have a feeling that there are some more out there.
David, I see a few more questions in the chat window.
Okay, so let me figure out. I feel WebEx kind of changes a little bit with how I'm using it, so let me see if I can figure out. View, no. Panel, no. Participant.
Well, there was a question about where can they get the presentation or recording. That will be posted on the community, so you can go right into the APM community. It'll be there either later today or tomorrow morning.
Okay, here we go. I found the chat window and the Q&A window. Okay, good. Yeah, the slides about APM 10 will be posted. Melissa and I talked about this before the call, so you can look at those. The slides that I showed about differential analysis, that presentation is going to take place at CA World in about a month, and I will make those slides available after that CA World presentation. So you'll have to wait on those, unfortunately. But all right, so here's the question. Let's see if I can get a few out of this. Is maintaining an application more like maintaining a robot, where when the robot malfunctions, there's some piece that needs to be replaced, or a short circuit where you can swap out a part and swap in a part? Or is maintaining an application more like sailing a ship, where you really can't afford to stop and swap parts, and anyway, it's always more complicated than that. Something might be partially working, and that may be okay in some situations, whereas, you know, in other words, you're just trying to keep the ship moving on a particular course, but it can be a very messy process along the way, and it requires an experienced crew and a captain. Which one of those metaphors do you think is most descriptive of what's the case? And I think with that question, this webcast may go down as most bizarre in CA Technologies history, which would be okay with me. All right, nobody's biting. I guess I put you guys to sleep. Brianna, is there any way to just open the line so that people can speak up, in case that's more convenient than typing? Because maybe folks are in their cars and they just can't.
Yeah, one moment. Okay, David, all lines are open.
Okay, great. So just in case somebody out there wasn't able to type in, let me know.
Wow, no
Okay.
questions. We have a quiet group here today, David.
Okay, that's all right. So then I guess with that, you know, my email address is up there, so anybody thinks of questions later, they can have it. Otherwise, we'll give everyone a few minutes back on the hour, and have a great day.
Wonderful, David. Thank you for delivering this to the community today.
Sure, sure.
Ladies and gentlemen, this does conclude today's conference call. You may now disconnect.